So this is the presentation that I gave at CF Summit in Las Vegas a month or so ago, which was super exciting to be back in person at CF Summit this year. And this is on message queues with RabbitMQ. So I've got the chat up in one of my other monitors, and I'll try my darndest to keep my eye out so you can put any questions down there if you have them. And this will be a little fun since I didn't get a chance to go over all of my demos to make sure they were working. So we'll find out. So, rabbity goodness. I'll put some links at the front of a slide deck. A lot of times I'll stick a bunch of links at the end of the slide deck. I'll just stick them here. Um, there's more than one type of message queue server out there. RabbitMQ is one of them. It's one of the most popular ones, one of the older ones. There's also things like ActiveMQ. There's some as a service versions like the Azure Message Bus or Amazon's SQS, I believe. For today, we're just focused on RabbitMQ and specifically the Rabbit MQ SDK, which I wrote. A lot of these concepts, though, can apply to other message queues as well. If you want to get started using Rabbit, I have a link to RabbitMQ. I also have a link to the ForgeBox package for the SDK. This is basically a ColdFusion wrapper to use RabbitMQ in your ColdFusion applications. This is out there in ForgeBox. I want to stress the RabbitMQ SDK is not specific to ColdBox. It does not require ColdBox to use. You also don't need ColdBox to use it. Also, ColdBox is not required. I am using a ColdBox app today just because it's the easiest, most efficient way to use it, in my opinion. But if you're not using ColdBox, do not worry. You can drop this in and you can use it completely standalone. Um, so don't worry about that. All right, let's see if I can consolidate my browser windows here. Drag you over to there. All right. I also have a link to the Ortus community, just in case you have any questions after the session you want to ask, and a link here to stop, and then some examples as well for delayed messages. Okay, so what are message queues? Message queues follow a publish subscribe pattern and it allows you to communicate between different portions of an application or most commonly different entire applications themselves via some sort of generic concept known as a message. So you have producers, which are parts of your application that produce a message. You have consumers, which are parts of your application that consume a message. Generally, message queues are most useful when you have multiple applications working together, possibly maintained by different teams of programmers, or maybe maintained by the same team, but you just want to scale them and deploy them completely independently, and you want to be able to share information between them without having the sort of synchronous nature of an HTTP call. Obviously, you could create an API, like a REST API, you could make an HTTP call from the client, to the API server, and you could send information, get information back. That's always inherently synchronous, and it's always something that if the remote server is down at the time, then that call just disappears, right? You lose that information. It's not stored anywhere. So the idea between the queues, you have some typically durable, intermediate, queue of messages that you want to communicate between platforms. It's asynchronous by default and if the consumer is not available at the time, it can get the message at a later date. So a message queue typically has some sort of broker that routes the messages back and forth, and in that case, this would be RabbitMQ. So RabbitMQ is the middleman, um, receiving messages from the publishers and then pushing them out to the consumers. ActiveMQ is another example. Kafka, I mentioned Azure Message Bus and Amazon SQS earlier. These typically always run as an external service. So they're not running, inside your ColdFusion server or inside the JVM. They're installed somewhere, running inside Docker, running on a VM, wherever you want to be. Doesn't really matter. But there's something that exists outside of your ColdFusion server, and it doesn't even have to be ColdFusion server because message queues can be glue between services written in different languages, which is actually a really powerful benefit to message queues. If you have a Java application communicating with a ColdFusion application, a .NET application, and you want to do that asynchronously through messages, they can all be publishers and subscribers to a message queue without having to be sharing the same language. And so this also helps consolidate work between scaled architectures. So if you have, some sort of Docker deployment or multiple servers behind a load balancer, and you want to be able to broadcast messages via some sort of topic that they all receive, instead of looping over and making an HTTP call to each individual server, you can use a message queue set up as a distribution that all of the consumers receive the message. So it has a lot of scaling benefits in that regard. So a message is a very generic concept. It can represent pretty much any sort of data or information that you want. A message has a destination address, which says where is the message going. It has a whole host of optional headers. I have a few of them here, such as the type, a correlation ID, a timestamp, expiration, reply to. Even a delay header is an option where you can delay the sending of a message. There's more headers. Don't worry too much about the headers because generally I don't really ever set custom headers, e except for in situations where I have a delayed message. Then you have the body of the message, and the body can basically be anything you want. It could be binary, it can be a string, it can be XML, it can be JSON. And yes, I know XML and JSON are strings. I'm just giving you ideas of what sorts of strings you might have. So typically, when I use the message queue, I'm sending JSON just because it's easy, it's readable, it's easy to debug, it's easy to consume, it's easy to create, and pretty much any language, whether it's Java or .NET or ColdFusion or JavaScript, is all going to easily consume JSON. The Rabbit SDK, which I'll be showing you that I've written, automatically will translate complex variables such as structs or arrays into JSON. So your code can just say, "Hey, here's an array to send," and behind the scenes, that just gets serialized to JSON and sent as a string-based message body. And then when you receive that same message back, the SDK just automatically deserializes that JSON back to an array, so it's sort of invisible. But the contents of that can be basically whatever you want. There's no limit on what you want to send. It's just whatever information you want to relay to the consumers. So, some terminology just to clear a few things up. Not that it'll necessarily make it more clear, but there's a lot of vernacular you hear. A producer is just a word that means some sort of code producing messages, i.e., sending messages into a queue or into a topic. Um, a queue is an ordered holding place of messages. Think of it as like an array, right? In RabbitMQ, if the queue is durable, that's going to mean that the contents of the queue are also stored on disk. So if you pull the cord out on the server, you don't lose all the messages in the queue. You can have queues that are non-durable, meaning they're only stored in memory if you don't really care that much about the messages. Um, a consumer is simply any application or code that's receiving messages and doing something with them. So you could be reading messages from a queue. You could be listening to a particular topic that could make that code a consumer. An exchange is a phrase that not all message queues have. RabbitMQ refers to the thing that decides where a message goes. That's the exchange. So I think of the exchange as your post office, right? If you have a letter and you want to send it to your friend, you might not know exactly where your friend lives, but you can write his address on the letter. You send it through the post office to the exchange, and they look at the address and they figure out where it needs to physically be delivered to. With Rabbit, when you send a message, you don't ever send a message directly to a queue or to a topic. You always send a message to an exchange, which then says, okay, where does this message need to go? Which turns into, what queues it might need to go into, queue or queues, plural, singular, what sort of consumers might be listening. All that's abstracted behind that initial point of entry, which is the exchange. We also have TCP connections and channels. These are very similar and they're a little low level. It's worth noting that RabbitMQ, as with a lot of message queues, have a concept of channels, and you can have more than one quote unquote channels operating over a single underlying TCP connection. Um, that's really just more informational, so you're aware. So if you have a consumer listening to a queue, there's obviously an underlying TCP connection, and there can be more than one channel on top of that, which is more of a just a mental model of the ability to you can send messages over a channel. Anyway, I once wanted to make that distinction. And then a routing key in Rabbit is what the exchange uses to decide where the message goes. So the routing key is basically the destination address that I mentioned here on the what is a message slide. So when you send a message, you have a routing key and it says, this is where I want the message to go. So there's a couple sort of high level message queue design patterns I'll talk about, and then I'll show some examples. So there's like a billion possible ways you can use message queues. There's a lot of different things you can do and ideas you can take it with. But there's really a somewhat small number of actual kind of design patterns. I call them design patterns. The first one is just sort of direct messaging. So we have the publisher, which is the P. We have the consumer, which is the C. I just stop and think of what the P stood for. I totally grabbed this image off of the RabbitMQ documentation. And so the red squares in the middle, that's our queue, right? So the publisher dumps a message into the queue. You have a consumer that receive the message using the routing key to decide what queue the message goes into. And this is the most simplest possible example you can think of, right? Two servers, one server wants to send a message asynchronously to the other server. Um, and just to confirm, the publisher doesn't receive any reply back. So it's not like a REST API where you send an HTTP request with a body and headers, and then you get some response back, right? There is no response to a publisher. They say, here's a message, they throw it over the wall, goes into the black box. The exchange says, all right, thanks, see you later, right? And it's like handing your letter to the mailman, right? You say, deliver this letter, and the mailman goes, okay. You don't get the reply from your friend right then. It's just goes over the wall and eventually will be delivered. So I just want to make that distinction. Now I do have an example I'll show you later, which is doing RPC with messages, which actually does wait for a reply back. But your traditional message queue pattern is just here's a message, it goes into the queue, and at some point in the future, in theory, a consumer will go ahead and take that message. But there's no guarantees on when that happens. We also have this, which is just kind of a minor variation on the first pattern. This is more of a publish subscribe or a fan out, if you will. And that is we have a single publisher and the X represents the exchange. Now, technically in this previous slide, the exchange is still there. The diagram just kind of glossed over it and didn't represent it. There's always technically an exchange. The publisher always goes to an exchange. Excuse me. In this case, we have multiple queues. So a message doesn't necessarily go to just one queue. It doesn't have to. You could have a message that went into two different queues, and it would be, a copy of the message would be placed in each queue. And then there could be different consumers listening to each queues. And that's why the messages always go into the exchange first. You never send a message to a queue. You only send the message to the exchange, and then the exchange decides where the message goes. I don't think I have, no. Uh, there's really another variation of this which could exist, in which there could still only be one queue, but there can be as many consumers as you want. There's no limitation that you can only have a single, consumer application listening to messages on a queue. You could have hundreds of consumers, all waiting. And the way that a queue works is the each message is delivered once to one consumer. Right. So if you put, let's say there's, 5 consumers all listening for messages, and you put 5 messages into the queue, in theory, each consumer would get one message, but the same message would never be delivered to 2 consumers. So they're always delivered in order. Um, with a regular publish subscribe, the message is sent to one consumer, whoever the first guy in line is, evenly distributed amongst them. And you can have as many consumers as you want. Then there's also topics. And topics are different than what I just described because even though you use the message semantics when you send the message, it no longer follows the only one consumer gets to receive the message. With a topic, every single consumer all gets a copy of the message. So this would be more for like broadcast or announcements, right? So here we have a publisher. They send a message, the exchange, the type is going to be topic, and then you can route the messages based on all sorts of cool dynamic routing rules based on the routing key. So we have like star dot orange dot star. So any message that was some text dot orange dot some other text would go to Q1, right? Um, there's documentation for how those rules work, but those messages are distributed to those queues, and then they're basically immediately delivered to all consumers. So with a topic, every single consumer gets a copy of the message. So let's say you had a cluster of web servers, right? And you wanted to reinitialize them in the middle of the day, and you didn't want to hit a URL on every single web server. You could just have a topic that said, you know, reinitialize, and you could send a message that said, "Yeah, do it now," and then all the servers, all the listening consumers, all get a copy of that message, and they do something. So, topics are very different as far as which consumers get the messages, which I think make them pretty powerful. And then there's also the RPC. This is when you want to undo everything I just said about message queues being asynchronous, and you want to send a message and you want to wait for the guy on the other end of a line, some sort of consumer, to take the message, do something with it, and then send you a message back. So this would basically be like standing on your front porch, handing the mailman an envelope, and then waiting on your front porch until the mailman came back the next day and said, "Your friend just replied, here's the message." Except it hopefully happens in only a few milliseconds as opposed to a day or a week. Um, the client basically just sends a message and then just waits for X number of seconds for a reply to come back. This is where the correlation ID comes in play because that lets you know which reply goes with which message. Which message? Each sort of conversation has its own ID, um, and there's a dedicated method in the SDK that helps you do this. You basically have to have a server running somewhere that receives messages that immediately pushes a reply back on some sort of reply queue. This can be useful for if you want to have the same basic flow as like an API call where you send some data to a remote server and you want to get a reply back, but you don't want to deal with the semantics of having like an HTTP based REST API built up. Maybe you just want to have a little microservice somewhere running a Docker container and you want to be able to push it some data and get some data back, but you don't want to have like a domain name and SSL certs and like the REST API framework, put in place. You just want to have just some low level, here's some data, send me something back. You can do that really easily with the RPC design pattern. So let's play with this a little bit because, excuse me, I don't want to talk too long without showing you something. Otherwise, it all kind of just doesn't make sense after a bit. Just a second. Okay, sorry about that. Got to get my throat cleared out. So you can install Rabbit a bunch of different ways. You can just run the installer on Windows. I'm pretty certain you can install it on Mac. I don't know. I'm not a Mac guy. You can install it on Linux. It can just be just a natively installed piece of software. My favorite way to run it is Docker, just because it has no external dependencies. It basically just works, assuming you have Docker already installed. And when I'm done, I can just stop the container and delete it, and it's like it never existed. So for my example, I'm just running this directly inside of Docker. So Docker pull RabbitMQ. This is a specific version of the image that comes with the management plugin already installed. And the management plugin is a nice little web-based interface that makes it really easy to administer. So you pull the image and then you just run it. So RM means remove it when you're done running it. D means run as a daemon or detached. We have some ports that we map through, and then the name of our image. Now, if you're using this in production, you can absolutely use Docker to run Rabbit in production. I do it all the time. What you'll want to do is you'll want to map in a couple volumes, which make sure that all the data that Rabbit uses all the users that are defined and the queues that are defined, all the messages in the queues. You map those to a couple volumes, so those are stored outside the container, and then every time you restart the container, all your data is still there. It actually works really well. Um, so I ran these commands earlier, like actually 2 minutes before I jumped on the call, when I was like, "Oh crap, let me get all this running again." And so I had this running locally. Um, if I do a Docker PS, I'm inside a command box, but you notice I use the exclamation point, so I'm just running a native command. So here's my Rabbit Docker container running, and so we can view. Oh, I already have it open. We can as soon as we have it running, we can view this. So this is on localhost port 15672 is the default port. So by default, the login that's created is called guest, and its password is guest. Um, Obviously, don't do that in production. That's just the defaults in the Docker container. There's environment variables you can use to easily override that. So I logged in with guest earlier, and so this is the little management console. I really like tools with web-based little consoles just because I think it's like a million times uh, easier just to kind of like wrap your brain around it and look at it, see how it works. Couchbase has a nice little web UI. Well, I mean, obviously, ColdFusion does. We kind of take it for granted as ColdFusion developers. A lot of other tools don't have any kind of web-based interface. So when we look in here, we can see the version of Rabbit I'm running is right here, version 3.11. And there's some graphs that will show up here when we're actually sending messages, but there's nothing going on right now on our server. We have 0 connections, 0 channels, and 7 exchanges, which come as default, and 0 queues, and 0 consumers. So this is really boring. This is nothing going on. We should create some stuff. Um, there's also you can come in here, you can look at the ports that are in use. There's some cool features to import and export your settings, which is kind of cool. This is actually somewhat new. And so I don't know, some of these pages are actually kind of boring until I create some stuff. Maybe we should come back and look at a couple of these pages here in a minute after I create some things because there's nothing to find. I will show you the exchanges. There are 7 exchanges that come out of the box that are just kind of automatically part of. Sorry, I clicked on something and they all disappeared. What did I click on? This interface has oh, I clicked on the specific topic. Sorry. I tend to click all over the screen, and when I click on random things, I don't realize it. So the AMQ.direct exchange is the same as the default. This is what you normally use when you don't specify an exchange. And this basically means send this message directly to whatever queue has the same name as my routing key, which is just like the basic bread and butter usage, right? Here's a message, here's the routing key, find a queue with a name that matches the routing key, boom, put the message in the queue. Fan out is an exchange when you want to send a message and have it route to multiple queues. AMQ headers is an exchange if you want to route to different queues based on headers. Uh, and then AMQ topic is the one we talked about where you have a topic distribution and all the consumers will receive a copy of the message. And the topic actually doesn't really even use a queue. When you send a message through the topic exchange, it immediately delivers it to whoever consumers are there, and then it's gone. Right? We don't really store those messages; they're delivered to whoever's home, and then we don't talk to them anymore. So let's jump into the code real quick because once we create like some queues and stuff, we can actually see them show up here. So what I have already created, I had considered creating this all from scratch when I did this for CF Summit because it doesn't take that long, but it takes just long enough. It would be a bit of a waste of time. So I kind of just have it all set up, even though this still only represents maybe 20, 30 minutes is throwing some stuff together. Um, in this folder, I have a just a template cold box application. Again, you don't have to use cold box, right? Don't be like, oh no, I can't use Rabbit because I don't use cold box. I'm just using cold box because it's amazing. That's all. So I created this basically by just typing cold box create app, and that just throws an empty cold box skeleton. If you want to dump Rabbit into just an existing application that's non cold box, it's not a problem. I installed the Rabbit SDK by typing install Rabbit SDK. That would be the same whether or not you're using Coldbox. That just downloads it from ForgeBox and dumps it into the modules folder. If you are like really against using things like command box, even to install, you can always go to ForgeBox, and you should be able to, yeah, you can just directly download it from the versions page. Nobody does that though. It's 2022 user package manager. So install RabbitSDK. Now I've already done that. And you can see that I have the RabbitSDK installed right here. So all that did was um, it dumped these files under modules RabbitSDK. Now, since I'm using ColdBox is going to just magically find this and it's going to load it all up and it's going to be mostly amazing. If you're not in ColdBox, it's not a problem. You just get to manually create these CFCs with create object or the new keyword. And either way, you do need to put in a little bit of boilerplate to load the jars. And that's because there is still not a cross-engine compatible version of loading jars on the fly that works in Adobe and Lucy, which is sad. So I think I have VS Code already running. Yep, it's just in my other monitor. So this is just a VS Code instance in that folder. Font size a little bigger, so hopefully we can see it all. Okay, so the only other piece that we have to do to make this work um, is our this.java settings and application.cfc. You need to go ahead and point to the lib folder. Like I said, I really hate, I just absolutely hate to use Java Loader in like 2022 because my gosh, Java Loader, it's 2022. But there is no way to load jars on the fly from within a module, which is really sad, at least not in Adobe. So this.java settings is basically what you get. So it's not that big of a deal. It's a little bit of boilerplate. I like to do this right here where I just point to the folder. I use directory lists and I tell it to get an array back. And then I just get a nice little array of jars that just get passed into load paths. That's my favorite way to do it. If later on you're like, what was that thing Brad said to use? Don't worry, just go to the description of the ForgeBox package, and it's right there in the docs. So those are the two things that we need: basically installing Rabbit and then throwing those jars so they'll get loaded. The Rabbit SDK will default to all the default ports on localhost with like the default login. So you can kind of just like spin it up. It'll like just work for like local development. On production, you'd probably need to change some of this stuff for, oops, wrong folder. Since this example is a ColdBox application, we would configure it in the ColdBox.cfc under module settings. We'd create a Rabbit SDK struct, and you could override whatever the heck settings you felt like overriding in there. If you're outside of ColdBox, you would just pass these in as settings to the module when you created the CFCs, not to the module, to the models. And if we look in the module config, we can basically see these are the default settings, which localhost, guest, default port. So if you needed to override those, you could easily do that. But I'm not specifying these because I'm just using the defaults. Oh, look, here's a comment where I was complaining about some stupid Lucy bug. Good times. Okay. So in my app, how do we actually use Rabbit? So in my main handler here, we inject our Rabbit client. So the Rabbit client is basically the main class for the Rabbit SDK. For the most part, 95% of all the methods you need to call are all conveniently placed in this Rabbit client CFC. The Rabbit SDK does wrap the Java SDK. The Java SDK is annoying and pedantic and lame, and you have to create like hundreds of ridiculous classes. And so we encapsulate all that nonsense for you inside this nice little CFC. This does all the Java casting for you. It allows you to use the consumer threads and everything, so it all just works. So I'm just injecting my Rabbit client. If you're not familiar with Wirebox and ColdBox, this is just the name of the CFC at. Oops, I just deleted that. Name of the CFC at the name of the module is all this whole convention is. If you weren't using ColdBox, you would just use create object and you would point to the Rabbit client CFC, which just exists under here, Rabbit client. You would just create this directly, and then you would pass in your configuration. Okay, so back to my example. Inject the Rabbit client, and I'm just going to use it right here in this little welcome to Coldbox page. Actually, while I'm explaining to this, I should go ahead and start up the site because it'll take a quick minute for it to come all the way up. I'm using command box to start my server because it's fast and it's easy and it's fun. Um, you're under no obligation to do that. All right, so I want to make sure that this is going to come up. Perfect. All right, give that a second to churn. So I injected the Rabbit client. It's just the word Rabbit because I like brevity. And so I have Rabbit Q declare CF Summit publish. Here's the body of my message. Oh, hey, the site's up. Here's the body of my message, which I'm declaring as a struct. Conference is awesome. Timestamp now. And then this is my routing key, which is where I want the message to be delivered to. So I'm not specifying an exchange. So by default, we're going to use that default exchange that just looks for a queue with the same name as the routing key. Nice and easy. Um, the queue declare is not required. This creates a queue if it doesn't exist. That method is idempotent. So you can call it as many times as you want. If the queue is already there, it just shrugs and moves on. I like having the definition of the queues in my code. That way, when I point some new functionality at say my production instance of Rabbit, I don't have to be like, oh crap, I forgot to go create the queues this requires. Right? It just kind of just creates them on the fly the first time the code runs. I really like that. I think kind of keeps the configuration in the code. You're not required to do that. You could just as easily have um, gone into Rabbit and said, I want to create a queue. Oops, sorry. You actually have to put a name in. You know, I could come in and I could just wait. I don't think I spelled it right. Queue. Well, I guess that is right. Word queue always just seems really weird. Right. So I can manually create my queue from the interface. But here's the CF Summit queue. As you can tell, my Coldbox app just finished booting up and it ran this line of code right here. And it just created that CF Summit queue. And then that displays in the administrator. And of course, the MyQ queue I just created randomly right now as my example. I'm going to delete this MyQ queue because I don't want it. Goodbye. You are the weakest link. Okay, so our code automatically created the queue and it sent a message. And if we look here, we have actually, are there any graphs on the homepage now? Sorry, just distracted myself. I forgot about the homepage. Uh-oh. Hello. My browser's being unresponsive. There we go. So now we have some graphs on the homepage now that we're actually doing some fun stuff here. So we have a graph that shows me all the queued messages across all the queues. And as you can see, it went from 0 to 1 about 30 seconds ago, and it's been sitting at one message, right? So we have one total message. And then our message rates in the last minute had a little blip there, but I just talked for a minute and now it is gone. You can customize these last minute, last 10 minutes. There we go. If I bump the graph out to the last 10 minutes, we have a little blip where we, sent a message. This is kind of cool. You can kind of just look at your Rabbit server and see how busy it is. And so if we go to queues, we see the CF Summit queue and we see there's one ready message, right? For a total of one. If you're wondering what unact means, I didn't really talk about it. When you're doing a topic or a topic broadcast, you don't really care if anybody receives it. It's just kind of like, hey, we're shutting down. Okay, whatever. But when you're sending a message into a work queue and you want to make that's an important message, you want to make sure that a consumer takes it and processes it. The consumers have the ability to acknowledge the message. And it's sort of like a transaction in a database, right? The consumer receives the message, and then when it's done processing it, it acknowledges, okay, I'm done. This message is completely, taken care of and we're finished, right? Or the consumer can reject the message and say, you know what, I tried to process this, but my database was offline and everything errored out, and the world is terrible right now. Put the message back in the queue. I'm gonna have to come back and process it again later, right? And the message will stay unacknowledged. Um, also, if the consumer basically times out, if it takes a message from the queue and it never acknowledges it ever, then eventually Rabbit will give up and say, okay, I'm guessing that consumer just like died, and I'm going to go ahead and put the message back in the queue. So that's if you want to make sure messages don't get lost. By default, unless you turn all auto acknowledge off, the SDK will just automatically acknowledge any messages it receives with the presumption that it'll process it okay. So that's something you control as the developer based on how important the messages in the queue are. If the messages are just informational, then you might be like, yeah, who cares? But if the messages are really important and you want to make sure that a message doesn't get dropped right when a server's down, then you'd want to say, don't automatically acknowledge the messages. And then in your code, the onus is on you to explicitly say this message is acknowledged or this message is rejected. So that's why we have this on act column, because if there's a message that's been read by a consumer, but it's still kind of floating out there in limbo and it hasn't been acknowledged or rejected yet, then it'll show up in this column there. So why do we still have one message in the queue? Because there's no consumers. So we dump the message into the queue when this code, oh, no, that's not VS Code. When this code right here ran, we dumped this message with this body into this queue. But there's no consumers listening to the messages, so the message is still just sitting there. So we can view messages from the web-based interface for debugging, pretty handy. So I click on the name of the queue, right? Here's my little graphs for the queue, and there's a whole bunch of junk down here. We'll notice that there's no consumers, which is why the message is still there. And then, oh, here we go. So get message. I can get a message off the queue. And keep in mind, the queue could be empty. There could be one message, or there could be a million messages in the queue. Um, get message will just get whatever the next one is. And queues are inherently ordered, so they're FIFO, first in, first out. Right. Um, by default, the acknowledge mode says to knack, which is a funny terminology, basically means reject, to not acknowledge the message and send it back to the queue. Right. So I can say, get me one message, and it'll get the message from the queue and it'll put it back in the queue so it's still there. So here it is, routing key, CF Summit, and here's the payload. Conference is awesome, timestamp, and in the current date. So this is the message that I dumped into the queue using this code right here. Easy peasy, mac and cheesy. If I tell this to automatically acknowledge the message and I get the message, then the queue should be empty. Did I do that right? Okay, let me try again. Try reject it. Oh, queue is empty. Okay, it did work. I think it worked last time, but since I had my graph set to last 10 minutes, it took a second for the resolution of the graph to show it. Okay, so when I changed it to get the message and not put it back in the queue, then the number of messages in the queue goes down to 0. Um, you're not going to be reading messages directly from here outside of just testing, right? You can also publish messages to the queue, which is actually kind of cool. Um, so I could just like make up my own kind of test message here. The payload's going to be foobar, and I can just say publish a message, and that'll dump this message directly into our queue here. See how long it takes for it to show up in the graph. And then I can say get the message and don't put it back in the queue. So there's my foobar message that I just dumped in the queue. Okay, so let's actually use a consumer though to get the messages, because you're not going to be just fiddling around with the messages um, inside of here. I should also note that our connections tab has gotten slightly more interesting the last time we looked at it. We now have a connection from this local IP address using the guest username, which is running. Um, and that is the Rabbit SDK inside of my Coldbox application, which I use to send the message. That's this guy right here. I'm actually surprised there's no channels, and I have a feeling it's because the channels probably time out. If I refresh this page, which should dump another message into our queue. Um, there we go. So there's our message. Let's see if we have channel now. Oh, you want to know why? Because I think the channels will only show up once I start my consumer. Let's go ahead and start my consumer. Make this more interesting. So, I could start a consumer inside of the Coldbox app, but just because I wanted it to be slightly more interesting, I've created a task runner. This is just a command box task runner, um, which will start a consumer and will automatically do something whenever a message comes in. So let's talk through what we have. It's not that complicated. If you're not familiar with command box task runners, these basically allow you to just run arbitrary ColdFusion code completely from the command line. Um, they're really fun and powerful. There's no web server involved, right? There's no Tomcat, there's no ports, there's no anything. It's just pure command line based execution. So task runners are a CFC, and they have a method called run. And whenever you run the task, this code just executes. So here we load the RabbitSDK module in. These run inside a command box, and command box knows how to load modules. I class load in the jars, which is the equivalent of what we did in the application.cfc of my Coldbox app. And then this is the equivalent of that injection we had in my main handler. I say, hey, get me my Rabbit client, right? And then I say, start a consumer. Rabbit.start consumer. This is the queue I want to consume messages from, which of course is CF Summit. And this is a closure that I want to run every time a message comes in. Now, this line of code, line 7 through 15, runs once and it runs instantly, right? But it starts a thread, a background thread in the JVM. And again, this has nothing to do with the web server I started earlier. This is all happening inside my command box CLI JVM. This fires a thread off in the background, which just sits and listens for messages. That's all it does. Are there messages? Are there messages? Um, and so the contents of this closure don't run until a message comes in, right? I'm just declaring the closure right now, and the closure will run at some future point in time when there's actually a message available for it to run. And when there is a message, I'm going to print a line message received. I'm going to print out the body of the message and flush that out to the console. Pretty simple. And then once I start the consumer task, I'm going to output the text Rabbit consumer started. And then I'm gonna go ahead and just sleep forever, right? My task is just gonna kind of sit here while this thread runs in the background. And the reason I do that is so when I hit Control C, I can go ahead and I can close the channel, which will stop that background thread. Otherwise, I would leave that consumer just running forever and ever in the background. And every time I ran the task, I get a new consumer. And I don't really want that. So I'm gonna have the main thread sleep just so I can stop that guy in the background. So let's give this a shot. This task is just sitting here in my directory here. So I do task run, Rabbit consumer started. Now there was a message already waiting in the queue, if you remember, because I refreshed the page a little bit ago. And so when I started the consumer, it immediately saw that message and said, "Oh, goody goody, a message," and then it processed it, which in this case just dumped out the contents of it. Right. So now the queue should be empty. And if I go back to my CF Summit queue, yes, our queue is empty. So can I get these side by side? See if I can get Windows to play nice here. My Coldbox page on the left is the page that dumps a message into the queue. My terminal on the right is my consumer that's running inside of a command box task runner. And again, remember, the consumer can be anything. It can be a Java app, it can be a Node app, it can be a Ruby app, it can be a ColdFusion app, it can be a task runner. It doesn't matter. The publisher can be anything. It can be all of those above. That's the whole beauty of this. So if I hit refresh on my browser on the left, I instantly see a message comes in on the right. So when I refresh the browser window, the Rabbit client installed inside of my little Coldbox web app running Adobe ColdFusion says, "Hey RabbitMQ, I got a message for you. Here you go." And then RabbitMQ says, "All right, I've got a message. I've got a consumer waiting. I'm going to push the message to them." The consumer is running the Rabbit SDK inside of my task runner, just kind of running as a daemon in the background, and it immediately gets that message. So the latency is very low. So when I hit F5 within half a second, that message is processed. In fact, if I just like spam the F5 button, um, it's going to keep processing those messages. So it's kind of fun to watch that. But that's really like the basic semantics of what it looks like to send a message and receive it. And it's not really incredibly complicated. And I love using task runners for my consumers because I can deploy a little tiny command box based Docker container using like Pete Freitag's mini box, super tiny Docker container. I can just deploy that out in my Docker swarm and just have it to sit and just listen for messages and just process them all day long. It's just a little tiny microservice, and it works really great. Okay, so let's talk about a couple consumer use cases. Well, you know what? I'll show you the RPC example, and then I'll go through the use cases because the use cases are basically the end of the slide deck. So let me show you the RPC example. So I'm gonna hit Control C. Um, closes my. Oh, actually, you know what? I'm gonna start that back up. Whoa, that is not what I wanted to run. Ah, sorry. Typing random things here because it's fun. Okay, I restarted the consumer just because I forgot. I wanted to come in here and I wanted to look at the connections while the consumer was running. Um, so under the connections tab, I now have two connections, both logging in with guest. One of these is my Coldbox app, which is a publisher, right? One of these is my task runner, which is a subscriber. And then if we look under channels, this represents our consumer. The consumer always goes over a channel, right? Well, technically, the publisher uses a channel as well, but it creates the channel and destroys it every time. Same TCP connection, right? So it's not like there's a lot of overhead in doing that, but the channel's temporary. Creates a channel, sends a message, closes the channel. The consumer leaves the channel open, which is why we only see one channel here. Um, So I just wanted to show that. This is a lot more interesting on a production server where you might have like dozens of publishers or consumers and you can and using different usernames obviously, not guest. And you can see the difference between all of them. But I just wanted to show that you can really see a lot of cool information about, how many publishers and I'm sorry, how many connections and channels and consumers there are. Okay. So let me show you the RPC example really quick. It kind of takes everything that we just put together, but the consumer is gonna send a message back to the original publisher. Here we go. So, again, the typical message queue, asynchronous, right? This code right here, publish, does not wait for a response. It just throws the message at Rabbit and it goes on with its day. Forget about it. Occasionally, I've had a few examples where I wanted to have a microservice sitting somewhere. In my case, it was a Docker container running off in Docker Swarm. In your case, it could be whatever the heck you wanted. Actually, in some of my cases, it's been a virtual machine, a Windows virtual machine running a command box task runner as a Windows service. Doesn't really matter. But I wanted to be able to throw some data at it and get a response specifically. Last time I think I had the use case in a slide deck, so I won't get into it now. But the RPC client allows us to basically send a message that looks like a method call. And we can essentially proxy to a remote method that's running wherever the server application is running. So using my Rabbit client, I'm going to say I'm going to create an RPC client, and this is the name of the queue I want to use. So CF Summit RPC is the name of the queue that it's going to use to communicate. And then I'm going to call the add method on my RPC client, and I'm going to pass 2 and 3, and I'm going to get the result back, which I will dump just out to the page in my view here. So what is this add method and who is doing it and how does it work? So I have another task runner called RPC task, which is just a variation on the consumer that we did last time. So we load the module like before, we load the jars like before, we get the RabbitSDK like before. But in this time, instead of calling start consumer, right? This is the old version, start consumer, right? Run a message every time it comes in. This time we say start RPC server. We give it the name of the queue, and then we have again a closure we want to run whenever a message comes in. We'll get two things. We'll get the name of the method that was called, which in this case is going to be the word add, right? Um, it's worth noting there is no actual method called add on the RPC client CFC. I'm using on missing method behind the scenes. So you could type like whatever the crap you want, right? Doesn't matter. It's going to funnel through on missing method. And then the server is going to say, hey, this random collection of nonsense is what was just called as a method. And the server gets to decide what the heck it wants to do in that case. So there's no real add method anywhere. We're just on missing method captures that, and that comes through as the value of this method parameter. And then args is a struct or array based on whether or not you use named or positional parameters of whatever the heck you would pass into that method. And then this closure gets to do whatever the heck it wants. There's another way of using this where instead of a closure, um, uh, you can just create an instance of a CFC and pass into it. And in this instance, it'll just match an actual method in the CFC with the incoming name of the method. And so you can just kind of seamlessly proxy through to remote CFC. In my case, just to keep the example as simple as possible, I just defined a closure where I just have an if statement, right? That says if the method name is add, then do this, right? So I'm printing a little bit of logging RPC call to method blank with args blank. And then if the method is add, I add them together. Otherwise, I throw an exception. So whatever you return from this closure will be what gets sent back behind the scenes across the response queue back to our waiting consumer, and that's the result that they'll get. All right, so it looks like this. I need to start my server. So task run, crap, what was it called? It was RPC task. Yes, it was. So task run RPC task, Rabbit RPC server started. You know what? Let's put it side by side again. All right. So the handler for this, oops, let me go back to my main handler in ColdBox. This is RPC example. So we go to main, come on, main slash RPC example. Um, and it looks like we have an error. That's interesting. My server shows that it received. Oh, let me guess. Now we get to figure out what I did wrong. Have an idea of what I did wrong. I'm just looking. Yes. You know what? I think I actually might have done this on purpose when I was presenting on the CF Summit just to show people what an exception looked like. This is what an exception looks like, everyone. Um, so here's what I did wrong. In fact, you can tell from here. So my server received a message with an RPC message with the method name of add, and the arguments are as follows: the value 2 in the key 1 and value 3 in key 2, right? So it's basically an array. For what it's worth, also our queues also has a new queue created on demand. So here's the problem. The arguments were sent through positionally. So here, when I called it RPC client.add, I just passed positional arguments. There was no names to the arguments. It's just argument 1, argument 2. And you see this reflected here in the console output. It came through as basically an array or a struct with numeric keys. But in my client, I expected named arguments. I expected it to be left and right as opposed to 1 and 2, which is why we have an error. So it is correct that it errored because that should not work. What's cool is that the exception that was thrown remotely, I say remotely, it's all on my machine, but in reality, our RPC server could be literally anywhere else, right? It could be anywhere in the world. The exception that was thrown on the remote client came all the way back to my ColdBox application, which is where on the remote server, I should have said, which is where my RPC client is. So any exceptions that are thrown on the server will be try caught and sent back across the wire, and you'll see that full exception here, just as though you would call that method directly. So now if I fix my broken code and I pass add left equals 2, right equals 3, and refresh. Now we have another RPC call that comes in. This time the arguments are named left and right. And now we have our result back here in the ColdBox land, result 5. So this is an example of what the RPC looks like. You use a message, but the client sits and waits until a response comes back. It will time out eventually. I think the default timeout's like 15 or 30 seconds. You can control it to make it shorter or longer. But basically, if it doesn't receive a reply within that timeout, then the client will just throw an error and be like, "Yeah, I don't know. I never heard back. Who knows what happened?" Um, but I can hit refresh all day long, and we see our server gets those messages and sends it back. So the client is really just kind of a little convenience deal for you that handles just sending a message back automatically to um, the code that originally sent it. So go ahead and shut down my client there. So back to the slides then. So I wanted to put just kind of a collection of use cases into the slide deck here because the examples, it's really difficult to show like real meaty, juicy examples like in like a 1 hour demo because it's too complicated to get off in the weeds of what it would look like in like an actual use case. So I basically just created a bunch of use cases of actual things I built for clients. Most of them are one client using RabbitMQ just to like get your creative juices flowing of how you could turn around and maybe use this, you know, tomorrow at work. The first use case that I used Rabbit for was for an incoming lead system to create internal follow-ups in a separate system without polling for new leads in the database. So I had a client it was in the travel industry. Somebody says, I want to go on a cruise, right? They'd fill out a form, they'd stick their record into a database, and they had a series of jobs that would run like every 5 minutes. It would basically say, "Are the new records? Are the new records?" Right, over and over again, every 5 minutes. And then when there was a new record, it would take the data, it would stick into it a different table, and then a separate job would run every 5 minutes and be like, "Okay, copy this data over here." And eventually, like 30 minutes later, the customer might finally get a phone call saying, "Oh, hey, we hear you want to buy a cruise." And by then, they're like, "Never mind, I already booked with the competitor." So we switched the entire system over to use message queues because the websites where the leads were entered were a completely different website running a different version of ColdFusion than the websites where they actually created the follow-ups and they, managed all the customer service stuff. And so we changed that to just be messages that could be delivered immediately. And then we didn't have to pull the database and say, are the new records, are the new records? When somebody filled out a form and said, shut up and take my money, instantly that message would pop into the lead system and we could deal with that. Another particular use case that I built for a client was aggregating real-time changes to customer sales made across multiple systems running different versions of ColdFusion and Lucy, and then pushing real-time updates to dashboards and firing related processes. So basically, they have sales going on all day long, and they used to have reports that they would have to run. They would go select against a huge database query and see what the current data was. But instead, every time a sale happened, we could just push a message that would say $100 sale, and it would just add $100, right? Or $50 sale. And then using WebSockets, which I didn't even have a chance to talk about, using WebSockets and Rabbit, we were able to have a dashboard that would just immediately have those real-time updates pushed out to the screen. I wish I had like another hour to talk about the WebSockets because here's the cool thing. Like one of the coolest things about Rabbit, which is why I prefer it over a lot of the other message queues, is Rabbit has a built-in plugin out of the box. You have to install the plugin, takes like 2 seconds, and it basically allows you to use WebStomp. And Stomp is a protocol built on top of WebSockets. So basically, RabbitMQ can act as a WebSocket server. And the beauty of this is, unlike like a ColdFusion WebSocket implementation, where when you send a WebSocket message, it just goes to that one server. Um, when you use Rabbit as your WebSocket server, then you can have an incoming message that comes from a user's browser that hits a topic and then can get distributed to multiple different ColdFusion servers, all running Rabbit consumers. And then it works the other way around. You can have your ColdFusion server or a random task runner off in your Docker Swarm says, I want to push this notification to all of my logged in users, right? And then that goes through a queue, comes across the WebSocket, and their web browsers all instantly get a pop-up, just like a Facebook notification, you know. But that's all built into RabbitMQ, and I didn't even demo it because I only have an hour. But it sits on top of the whole message and queue semantics. So you use the same topics and queues that we looked at in our demos, but one of your consumers can be a web browser and you can just drop in any stomp.js library, which you can download off npm. And you have, you put in username and password. You could subscribe to topics, subscribe to queues. Um, it's super powerful and cool, and that's part of what we used for this feature, be able to push real time updates, and we used RabbitMQ for all of that. Which basically takes me to my next slide. Using the Stomp Rabbit plugin to push real-time messages to sales team agents as soon as new leads came in. So we used the topic exchange to broadcast leads only to applicable team members and enforced security via an authentication API. So we had an application that used JWTs, that's JSON Web Tokens, for login, and they had a bunch of travel agents out there. And when somebody filled out a form that said, I want to go on a cruise with Carnival, right, or Norwegian whatever, then instantly they could push a message via WebSockets that would pop up on the screen of all the agents that subscribe to that specific subtopic, right? So I only care about leads for people wanting to travel on Carnival or on this cruise line. And so we're able to use the topic distributions of Rabbit to be able to push those instant messages to a subset of the people out there. And then we used their JWTs to be able to authenticate the browsers. So every person's browser isn't just using a hard coded username and password, which is what every single demo of WebSockets Online shows, a stupid hard coded username and password, which you would never ever use in production. We were able to tie their Rabbit consumer directly back to their actual user via custom authentication API, which I wrote in ColdFusion. Um, I wish I had time to demo it. It's really cool. It's not even that complicated. But if you have questions, like ask me about that later. Um, it's pretty cool. We also built basically a real-time chat between a Twilio-powered SMS client and then a web-based chat UI that kind of looked a lot like Slack on a site, so sales teams could communicate with their clients. So a salesperson could go on, they could say, "I want to send this client a message." They would type a message, and it'll interface look kind of like they're using Slack or like a chat program, and then we would drop that message into we would use WebSockets powered by Rabbit for the browser to push those messages out. We would use the Twilio API to send a text message to the actual customer. And when their customer replied via text message, right, we would use the WebSockets powered by Rabbit again to push the reply directly back to the web browser. So the salesperson had like a real time web based chat over WebSockets, and they're chatting with someone over text messages, all with Rabbit in between. That was super cool. If you can't tell, I enjoyed building all those things with Rabbit. Another really fun thing, I mentioned delayed messages. I created a delayed notification system for a client to be able to follow up with unread messages. You know how like Slack, if I keep using Slack as an example, I assume everybody uses Slack. If somebody sends you a message on Slack and you have Slack open and you read it, perfect, no problem. But if you don't read the message on Slack, like 30 minutes later, you'll get an email from Slack that says, "Hey, somebody messaged you. You haven't read it yet." Right? They wanted to do the same basic thing that said, "Hey, somebody messaged you. It's been 10 minutes. You haven't replied." Right? And so we used the ability to send delayed messages. So whenever a message would come in, we would drop a message, we drop an additional message into a queue that would be delayed by 10, 20 minutes, however long the delay was. And after that much time had passed, it would send a follow-up that would check and see if the messages was still unread, and if so, it would annoy the heck out of the customer service person and say, "You haven't replied to this person. You need to reply." And that eliminated the whole database polling again, where we used to just hit the database and do this massive select, like, every minute looking for messages that were a lot older than 20 minutes that hadn't been read, and all that went away when we just started using delayed messages, in Rabbit to schedule these follow-ups. Um, we also used it to create user-specific notification queues, which we pushed over WebSockets. So each queue topic is locked down to a specific user. And again, our authentication was provided by a ColdFusion-based API that used the JWT for that user to identify the browser connections. This was basically kind of like the Facebook notification system, right? If you have Facebook open and someone like sends you a DM or post on your wall, like instantly the little red, one or two, pops up with a number of unread messages and just gets pushed directly out to your browser. We built the ability for a customer to be able to send similar notifications to anybody logged into their website. And it could be, your service request received a comment somebody sent you a direct message. Here's a system notification, right? And they could push these out, and each user kind of had their own separate, notification queue, all based on Rabbit, all based on WebSockets. Um, and it worked really great. It added a real kind of real time feel into their application. So that's the end of the customer use cases. There's a lot more things you can do, but those are just kind of a smattering of common things that I've done already for customers with Rabbit, and maybe you're seeing some of those thinking like, okay, I can kind of see how this might be able to fit in. I should have added a use case to talk about the RPC. Um, the RPC example was for a client that had their main application deployed as Linux Docker containers and Docker Swarm, but they had a couple silly old processes that were specific to Windows and the net command in Windows, and they needed to run on an actual Windows machine that was on like a domain, and we couldn't figure out how to make that work on Linux. So we threw a Windows VM out on their system, ran a command box task runner as a service, right, which ran a little RPC server, and then their application running on the Linux Docker containers just used the RPC feature to be able to make a quick call over to the server. And we didn't have to build a whole REST API. We didn't have to have any of the HTTP semantics in place. We're able to use just the Rabbit RPC client as a real low level, low latency way to shove messages back and forth over to that Windows service to be able to do those, LDAP specific things and get the message back. So that was my use case for the RPC client that I showed you guys. Okay, so that's basically the slides. I have a PDF of these slides. I don't know if I can share files like right here in Connect or not. Um, I tweeted the slide deck out, and I can find a way to provide it to anybody who's curious, because it does have the links and stuff in it. But that's basically all that I have for the presentation, unless anyone has any questions. And Porva, if you can let me know if there's a new way to send a file directly um, in Adobe Connect, that would be great. Let me just see if I can randomly drag and drop files and see what happens. Nope, drag and drop does not work in Adobe Connect. Dang it, it was worth a try. Actually, you know what? I'm pretty certain I have this file on Google Drive, and I can just share it from there. Wait to see if anyone else has a question. I will see if I can find. Ooh, here we go. October 3rd. Get link. Copy link. Anyone with the link as a viewer. There we go. That link to Google Drive should be to the PDF of the slides that I just showed, which includes the links that I covered. Yeah, I mean, I wish I had like more time to like go into all the crazy cool stuff Rabbit does. Really got a chance to scratch the surface. Um, but yeah, links and how I did the authentication. That's a good question, Jeff. I I really kind of wanted to do like a blog series or something like talking about how I did it because while it wasn't insanely complicated, it took me a while to figure it out just to know what pieces to put in what places. But unfortunately, everything I did was all specific to a client, which I couldn't just share that code, and I also have like zero time, unfortunately. Um, Basically, RabbitMQ, if I could figure out how to type here, RabbitMQ has the ability to um, make your authentication mechanisms pluggable when like a WebSocket connects. So by default, when a client server wants to connect to Rabbit, it just uses these usernames here, right? And you can create additional users, kind of a hard coded list of usernames, which is fine for simple things. But Rabbit has an entire pluggable architecture where you can specify additional authentication mechanisms, which can be LDAP based, or they have a whole bunch of kind of built-in ones. What I tapped into is the auth backend HTTP, which is basically a I think this is the right one. They may have moved this repository somewhere else. Yeah, here we go. Unfortunately, I think they combined a bunch of their extensions into one like large repository. Let's see here. I wanted to see if I had my goal is try to get a link that's actually unique. I'm just put this link, even though this isn't a folder link. Basically, there's a an additional plugin for Rabbit you install, which is the HTTP based authorization. I also used it in combination with a cached authorization plugin, which basically just caches the calls so you don't hammer your API. And then this basically has a very simple um, definition of an API you need to build. So in the configuration, you basically tell it what API endpoint to hit for, and there's multiple types of authorization and authentication, right? You can authenticate or authorize on the vhost, the resource they want, the topic they want. So you create an API somewhere. I created it just a really simple cold box, API. But you can do whatever you want. Whatever the URLs, you plug them into the configuration, and then each of these API endpoints will receive I forget if the URL variables or form posts, but they receive the data about somebody wants to connect. This is who they are. This is what they want to access. You run whatever the heck code you want to, right? Look up that user in the database, figure out if they have access to it, and then your API just returns like the text OK or something else. It's a very simple API. You just basically give a thumbs up or a thumbs down about whether or not that user should have access to that thing. And then whenever a new client, like a Stomp WebSocket, tries to connect, Rabbit will use your API and say, "Hey, I got some user wanting to connect. Do you know this dude? And does he have access?" And you get to give the thumbs up or the thumbs down based on your code. Um, it's really not that all complicated. You just kind of have to dig through the docs and figure out what data they pass you and what data they want back. And then, it's up to you to figure out how you want to configure it. Um, Rabbit can be a bit of a pain in its configuration files because Rabbit's written in Erlang, and Erlang syntax is weird and makes my like eyes bleed. Like this here is an example of what like I don't know if this is an array literal or what it is, but like this period here, gosh, you forget that period and your server won't start. Stupid Erlang. Anyway, sorry. I have some like PTSD from messing with Rabbit's configuration files. But once you get it, it actually works great. But that should get you started. And if you have any more questions on how that auth works, I can share some more stuff on like the community forum if you want to ask. But yeah, that's how you basically can provide your own custom authentication where you look it up in a database or whatever. Okay, quick questions. Blah 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 blah. Are the acknowledgments, if enabled, stored for future references? Tejas, you'd have to explain to me what you mean by that when you say the acknowledgments. I'm not sure what you mean. Maybe you can explain that question. Um, Jim said he had not thought about integrating WebSockets and message queues. Yeah, exactly. And I think that the whole WebSocket aspect of RabbitMQ makes it really, really appealing because the message semantics just work really naturally with it. And you don't have to have if you want to, push notification out via topic to all your WebSocket consumers, you don't have to do anything different in your ColdFusion code than just this, right? I mean, you're just publishing a message to Exchange is literally all you're doing. Except for instead of being a queue-based exchange, it would be a topic-based exchange most likely. Um, but it looks from the publisher standpoint just like any other message publishing. The fact that it's a topic with WebSocket-based consumers is just a completely unrelated, concern, which is what I like about it so well because it really abstracts it out. Okay, you asked when the consumer sends a response with a success or failure. So if the consumer consumes a message and acknowledges it, meaning everything's good here, then the message just goes away, right? The message is gone. It's possible for you to create an exchange that would place like a copy of every message into another queue or something. I'm not exactly sure why you'd want to do that. That could fill up pretty quickly. If the consumer rejects the message, then it just goes back into the queue. I'm not sure off the top of my head if Rabbit itself logs that anywhere. What I typically do is in my consumer code, if something goes terribly awry and I need to reject the message to try again later, I log it myself. I like to use Sentry.io, which I use the self-hosted version, which is great for logging, or just any kind of console output that goes somewhere. Usually, I take it upon myself to log if I have a problem. Um, I don't know if that answers your question, but let me know if you still have more questions. Okay, perfect. These are great questions. There's obviously like a lot of little nitty gritty things here that I glossed over. That can take a little while to get used to. Okay, any more questions? Don't want to leave anybody hanging with burning questions. I like how we have someone in the chat called air fryer turkey leftovers, making me hungry. Either that or your parents just really hated you. That's your real name, in which case I apologize. Logging is a good topic though. Is any of it automated? I'm not sure entirely what you mean. RabbitMQ has some logging in its own console. Like if you were to I'm probably gonna get the command wrong. Like if you were to is it logs? I suck at remembering Docker commands. Maybe just logs. Oh, it is. That's where I use stuff like Portainer to help me with Docker. I mean, if you look at like the console logs, right? Like this is just all the junk going out to the console in my actual like RabbitMQ Docker container, which does include some things like, failed logins and stuff like that. But Rabbit doesn't really log everything that happens. And I mean that's kind of by design because like one of my clients uses Rabbit for a lot of stuff, including tracking every time somebody freaking clicks their mouse, right? Every time you click a mouse on the web page, they shoot a message off that says user is still active, right? And they get like 12 to 15 incoming messages per second all day long, which translates to just thousands and thousands of messages every day and millions of messages every month. And I mean, they wouldn't want to log all those, right? They'd fill up a hard drive if they tried to log everything. So generally speaking, if you want to log something, like you do it, right? That's up to you, man. Like you log whatever you want, wherever you want to do it. But Rabbit itself doesn't really log anything just because it's made to process millions and millions of messages with super low latency and do as little as possible with them. And it's up to your application code to decide what you feel like logging. So, I mean, logging is whatever you want to do with it, but Rabbit itself isn't really going to log anything. That's entirely on you. Um, all right. Message request, responses, failures, timeouts. Yeah, that's up to you. One of the great things about Sentry is I also wrote the Sentry. Well, I mean, it's a copy of other people's work, but I made the module based version of the Sentry SDK. And you can install it in the Coldbox apps and the command box CLI, and it automatically listens to the on exception interception point. And when any of my task runners or Coldbox apps have errors related to Rabbit, Sentry just automatically gobbles up the messages and sends it off to its web interface. So I don't really have to lift a finger. That kind of thing just sort of quote unquote just works. Um, with my error handling. But yeah, lots of ways to do it.